Adding and subtracting rationals, day 2. What we're going to do here is we're going to solve these complex fractions by clearing the denominator by using the common denominator of each fraction in the numerator and the denominator. So what we'll start with here is by determining what that common denominator is, and that common denominator is 3x. I'm going to then multiply the top and the bottom of this by that common denominator. When I do that, I get a simplified version, 3x over 3 divided by 9x over x. When we multiply by that common denominator, it will clear the fraction in both the numerator and the denominator, leaving a single fraction of x divided by 9. Now, even though the numbers get more complex, it's not a big deal. Remember, this is the difference of two squares, so that means that the common denominator here is going to be x plus 1 times x minus 1. Once I do that, I multiply it through, and this will cancel with that denominator entirely, leaving me x plus 1 on the top. This will cancel with that, leaving me x times x plus 1 on the bottom. When the two quantities are canceled, the final answer is 1 over x. In question number 3, it gets a little bit more complex, but it's not too bad. You're still looking at the common denominator of these three fractions right here. That common denominator is 2x. I'm going to multiply that through. Remember the distributive property here. You're going to distribute that to both fractions inside the numerator. You get 6x over x plus 2x squared over 2 divided by 2x times x minus 1 over x. You can see that your values will clear and you're left with 6 plus x squared divided by 2 times x minus 1. Question number 4. This common denominator is pretty complicated, but it's actually very simple. You take the most number of x's and you take the most number of y's, and that is your common denominator. X squared y squared over x squared y squared. Remember, you're distributing this to all of the fractions inside. So now, when I do this, I get x squared y squared divided by xy minus x squared y squared divided by y squared. On the bottom, I get x squared y squared divided by x squared y minus x squared y squared divided by x y squared. Use properties of exponents to simplify, and you get xy minus x squared in the numerator and y minus x in the denominator. Take out your GCF of the numerator, which is an x, and you get y minus x over y minus x. Cancel your quantities, and the answer to number 4 is x. The common denominator here is just x minus 4. So you're going to multiply x minus 4 in the numerator and the denominator. 3x minus 4 over x minus 4 divided by x minus 4 minus, remember you're distributing this, distribute it to the 1 and to the second fraction, 2 times x minus 4 divided by x minus 4. Use your problems, and now I get 3 divided by x minus 4 minus 2. 3 over x minus 6 is your final answer. Our final example that we're going to do here is question number 6. In question number 6, you have negative exponents that you must deal with before moving forward. You do not move these to the bottom of the existing fraction. Instead, you have to create your complex fraction by moving them to the bottom of their own individual fractions. Your common denominator is xy, because that will clear every single fraction. So that means I'm going to distribute xy inside on the numerator, and I'll distribute xy inside on the denominator. Xy divided by x plus xy divided by y all over xy over x minus xy over y. Cancel. On the top you get y plus x. Cancel. On the bottom you get y minus x. Please take the time now to practice the following 3 problems. Make sure that you're looking for that number that will clear the fraction on the numerator and the denominator. Look closely at number 9, and you've got common denominators to find in the numerator before you actually find a common denominator across the complex fraction. Be ready to be prepared to come to class tomorrow to discuss what you've learned and the things that you still need to practice further.